So, welcome. Glad everyone can come to ClueCon. It's always our favorite time of year. We're glad to be back in August where we belong. Almost every ClueCon has taken place in August. We had a little setback in the last couple of years, as did the rest of the world, so I'm glad that we're kind of back on track to the way that we're used to things. So, just want to get started with a little bit of history. ClueCon was founded in 2005. We made it 15 years in a row as live, and as we all know, in 2020 it was a little harder to do that, so we did one virtual ClueCon. But we're back and we're starting over. We're at 3 and counting live. We're going to be back here in this same place next year, so if you think it's a pretty cool place, you can already start thinking about your plans next time. And then talking about FreeSwitch, it's been a pretty long time there too. FreeSwitch is 1 year younger than ClueCon. We released the first version in January of 2006. And we just released version 1.10.10 just 2 days ago. So give a big hand to all the people that worked really hard on making sure that that release came out. So now I just want to talk a little bit about like how do we even get here from where we were. In the beginning, this is what we had. We had one computer and 3 crazy people who thought that they could invent some kind of new software paradigm, right? So we had this idea. There's a lot of stuff, it was like a lot longer ago and there wasn't so many creature comforts and technology that we have, but it was still pretty technology advanced. You know, 2005, it's, you know, in the new millennia and all, but it was still, you know, servers and the internet were harder to get to and that kind of thing. So we had to make many things from scratch, right? So we had some stuff to work with, but all the things we wanted to do just weren't there. They're in our heads and they weren't, you know, out there and usable. So this is basically what we wanted. We want to take over the world and make a giant software-defined telecom network that will allow us to communicate completely through the internet. But this is all we had to start with, right? 2 lines of code, a bunch of ideas. So we spent a lot of time just working on trying to figure out like how can we get this crazy idea out of our heads and start going. And then this is a small excerpt from a video I made a couple years ago to kind of demonstrate like how did we start completely from scratch. And you can kind of see this visualization. This is us like basically, it's playing at full speed. That's interesting. Well, anyway, you can kind of see it. Gotta go. Here's nothing, and it's a visualization of all the code being written. It's kind of fast forwarded, so I don't have to torture you. So, in 18 years, we wrote 1.2 million lines of code, 37,000 commits. So it's been a pace of 6 a day for almost 20 years. So that took a lot of effort, and you would think that with all this work, we would say, are we there yet? You know, have we achieved the thing we want to do now? So, sort of, not really. We got the kind of one of the main components done, but then what else do we have to do still? The way we look at it every day in recent history is that like there's this, all the power is like in this orb that no one can get to, you know, because there's a lot of people out there that aren't willing to go deep into the depths of DevOps land and go and build and create all their own stuff, right? Like, and run their own infrastructure anymore. And we have this thing we want everyone to see, but we can't get to it. And that's one of the reasons that we started SignalWire in the first place. It's kind of the continuation of the plan that we've kind of hashed sometime in the mid-2000s, that we would be able to make a communication network that was completely built out of software and allow some of the cool stuff that we invented to actually get in the hands of everyone. Because, you know, FreeSwitch, kind of like the human brain, is only used maybe 10% of its functionality by any one person because it's so vast. One day we went to try and document all of it, and I think we're still doing it from 10 years ago because it's like impossible to kind of iterate and explain every single inch of what it does. But a lot of that functionality is very important, and getting to it was very hard. One of the reasons that we kind of started the whole thing was that so you wouldn't have to go through so much trouble. Because at the time when we wanted to do telecom in the old days, you had to get this physical equipment. It was very specialized. You had to like put it in the right place, and you had to get fit circuits, and then you had to like buy it from people who you were talking to, resellers, and get them on the phone, and they wouldn't tell you why the circuit didn't work, and all this kind of stuff. It drove us nuts, and we really wanted to do something about it. One of the things, I kind of talked about this a little bit last year, but back then it was just at the cusp of beginning the implementation phase of something that we had been dreaming about for a long time. And we call that a call fabric. We've been working on this conceptually since the minute we started FreeSwitch, right? Like, in order to build this, we had to build FreeSwitch first, and now that we have it functioning and scaling, and converted completely to software, because the first FreeSwitch ran on hardware still, and we had to do a lot of stuff to make it work in virtual environments, because almost all compute is virtual nowadays. So you go online and run it on DigitalOcean or something, you don't know what you're getting, VMs. And the physical hardware used to make it a little easier to do timing, because voice over IP and stuff is all timing based, and you would just like, borrow something off the motherboard, and all that's virtual. That took us a long time to get right, but now that we have this kind of computing fabric that we can distribute to almost anywhere we want, we can have a network with Raspberry Pis and Xeon servers and virtual servers all working together. We wanted to be able to figure out how the first way to kind of roll some of these features out. So we have some really big plans for the next year. What we did to start was something that's been a long time coming. We call it SWML, the signal wire markup language. And so I have basically described here is that SWML is what gives the developer their power. It's a markup language created by all communication needs. It surrounds us and penetrates us and binds our apps together. And I guess I could put that a little more simple or more technical. It's a document-based time slice of FreeSwitch power, accessible from WebRTC, SIP, PSTN, take your pick of protocol, and controllable and extensible from things like webhooks and WebSockets or any other integration points that you might have in your own private stuff that you're building, right? So an even easier way to look at it is a hunk of JSON or YAML that controls calls and makes features accessible. So the premise behind this is that we have so many endless combinations. I think there's like 750 different variables alone in FreeSwitch to control things and behaviors and modules and configuring stuff. A lot of it is kind of very fine-tunable, but also like allows you to kind of break everything yourself if you don't know what you're doing, including us. Like sometimes, we made it and we still get lost in it sometimes trying to remember how to set it up right. So with SWML, this is probably not that easy to see on the screen here, but it's kind of an example of a more elaborate SWML script, but it's written literally in like one ounce of YAML here. So it basically tries to make a call. If it doesn't work, and implements like a voicemail application all in kind of one expression of markup. So this YAML actually gets transferred into JSON and then parsed by our system. So you could have written it in JSON also, but I find it's better in human readable form to compose it this way. But you can also use programmatic toolkits to generate scripts like this using programming. So in case you want to do it, you can make static things that have different sections in them. So you can build a voice menu with 5 different areas and transfer between them all instead of having to just build everything separately. So you don't have to keep hitting the server every time something different happens. You can actually express an entire call as one static document. All right, and I'll zoom in a little bit on this. This is just the top of it, so you can see it's just like, if anyone knows I didn't really like YAML personally, but it kind of grew on me in the last couple of years because it's just a lot easier to compose things that you know what the data structure really looks like, and you don't really have to waste all your time trying to code all the little brackets and stuff, and it'll become JSON at the end. So you can just do this kind of array of applications, and it gives you the ability for all kinds of different things. So like we have all these basics like answer and play and connect as to place an outbound call, these verbs are extensible. So not only can you kind of add your own to this, you can put webhooks in it and you can deliver part of it, or you can get more cool ones that we make up at Signalwire that will add that take more complex things and make them into just a couple expressions of SWML rather than like complicated programming. And if anyone's ever used our Relay product, which we've worked on ahead, this is more like a static access to all the same functionality of Relay. So there's also Relay, which is a WebSocket-based interface that essentially gives you the ability to control the calls using similar syntax, only without having to exit your program. So you can write, if you're doing a tight loop and a lot of integrations with things, you can choose to use that. Okay, so some of the main points of SWML are that you can do these multiple contexts in a single document. You know, let's say you had a menu tree that has like 5 different sections. You can put all 5 sections in there. The calls can, you know, based on what the user says or does, you can jump around inside of them. So you can explain like your entire call, and it's extensible. Kind of went over that already, but it's also very horizontally scalable because it isn't very. All you have to do is generate a document, right? You give it to us and let us do the rest, and we can deploy that almost anywhere on the planet and run it like 1,000 times, and it scales really well. It's very interoperable with FreeSwitch also because anyone that likes using FreeSwitch on the ground somewhere can connect up to Signalwire and put it in front of, say, you might have like 100 FreeSwitch boxes and you want to have one main place, answer all your traffic and route and pick which one to route it to, and does all that kind of stuff too. So it's basically one of the most first kind of fundamental building blocks of what's coming in the rest of the call fabric plan. And what's coming very similar fashion to that will soon be management of registered users that are protocol agnostic. Right, so instead of just having to pick something like I'm going to use SIP for this, I have to set up a server and build a database and have a bunch of users. We're building agnostic subscribers that you can create at Signalwire, and then you can register to it using anything. You can use our SDK through WebRTC, you can use SIP, you can use the PSTN. You can build those paradigms, allowing you to focus more on if your product is some kind of UCAS-based call center, you're making the part that actually makes your product rather than some of these infrastructure things that are just a big distraction. And one of the things we did for people that wanted to get started really fast and maybe don't want to even dig that deep into the SWML itself, we made a call flow builder. And that is essentially a visual representation of the SWML. So when you use that, you can actually just create a flow chart. This is just an example of one of them. That'll underneath will give you SWML at the end, right? You could make something with it and look at it and then decide, you could read the code yourself and try and make something like that by hand, or you can prototype it as a graphic. And as we come out with more features and verbs and integrations, then it's easy to just throw them on this visualizer and it can drop in and like create a call flow instantly. And all the same benefits as you make something with this, it's instantly deployable and automatically can send as much traffic as you want to it. So one of the most important things about this is we didn't only make this because we thought that everyone out there in the world would find it interesting. It also helps us build more Signalware. So when we build more stuff internally, we can use some of the same technology to quickly enhance and launch more products. And one of the newest ones that we did this with that are kind of focusing on this year is our AI agent. Okay, so when we decided to make this AI agent, we wanted to figure out how can we take this 20 years worth of mechanical software that can do all the different, listening to someone talk and generating speech and playing files in unison and being able to say stuff and all the tools you ever wanted to make an IVR, and enhance it with something that could help make it a little easier to interact with. Because no matter what you do, if you try and build a voice menu programmatically, you're going to eventually run into a brick wall by accident, or it's going to get stuck and someone says something wrong and it hears you and all this different stuff, right? So we're like, when we looked at this, there's a giant craze of AI. Obviously, we're not special because we thought it was cool. But literally, someone spent $1 billion to make sure we all thought it was cool. But when we saw it, we were like, this is really kind of a missing piece to something we've had. It's like almost like we built this robot already and it just needed a brain. So like when we took this idea, like how can we get this something we can build and get out the door right away, we actually just integrated it with SWML. And the fact that SWML existed allowed us to extend it and make it very easy and programmatic. And then that, because it was so structured, then allowed us to make a UI out of it that, and if you don't want to get into the nitty-gritty of programming an AI bot, then you can just fill out some forms. In fact, we have a bunch of the functionality being abstracted into something that is pretty much drag and drop. So I know what you're thinking, like we're going to start Skynet. But, I would say that if Skynet existed, maybe this ClueCon would be where they'd come back to try and stop us, and they're not here, so I think we're okay for now. I'll give you kind of an example of just like what we're trying to do with the AI stuff is, here's a little flow chart. You have your happy caller over there. He interacts with a virtual agent who is a frontline SignalWire, and it makes decisions based on rules that you give it on how to interact. And I know if anyone was here yesterday, some people were using it to torture people, which you can use it for that too. But it's actually useful as well, so it can do just as much good as it does harm. And we prefer the good stuff. So you take the agent, it orchestrates everything, and then it feeds it to our top secret proprietary technology down there in the hamster wheel. And that integrates to any API that you've ever used before, right? So we can take an API that exists, either you made it for yourself or you're consuming it from a third party, and we make a gateway. We call it the SignalWire AI Gateway, or SWAG for short. We can essentially work together with the AI, narrow its field. It makes decisions that it needs to execute some kind of lookup or do an action or a behavior that is remote. It will invoke it. It goes into our proprietary secret hamster wheel, and it will go into the API of your choice, collect the information, goes all the way back through, and it talks to the user. So this gives you the ability to not just make funny conversational humor stuff, like you can also actually open a ticket or have it reset your equipment if you were some kind of support service, or you could have it, anything you can dream of that requires some kind of REST API, you can actually integrate it into the system and make it into a voice menu that doesn't matter how you say or ask for something. The only thing you can do wrong is be too vague maybe, because it's very good at kind of finding holes in what you say, but if you say, talk to it normally, even one word, like you don't trust it and you talk to it like normal, everyone's just like human support, like it'll play along with that too if you want it to. But if you call SignalWire main number, you can talk to it. We actually have it live answering our phones, and you can use it in the SignalWire lounge. There's a phone sitting there on the desk. If you pick it up, it'll call into our example. So we trust this thing enough to answer our calls, and it's been doing a good job. It will route calls to the right people. If they ask for support, it sends them support. It'll collect information. It can tell you like basic questions that you don't have to transfer to someone, and it's always happy to bow out if no one wants to do it. But the only thing that we found is that people are starting to enjoy it so much they stay on the phone with it extra time. So I just have a demo. There's going to be a whole bunch of these demos everywhere, so I don't want to steal everybody's thunder, but I just had like a recorded one that we put in a recent livewire. Although the last video I tried to play had this negative effect of playing at full speed, so I don't know if the same thing's going to happen. So let's see. Yep. Another pre-recorded demo doesn't work, so I'll just call one of my dev servers and do a real one.
Hello there. I am Sigourney, a demonstration of SignalWire AI agents. My purpose is to help you find a restaurant. Would you like me to assist you in finding a restaurant today?
Yes.
Great, let's get started. To find a restaurant, I'll need your address. Could you please provide me with your street address and zip code?
I'll use my home address because I don't know what the one is here.
Thank you for providing your address. Now let's move on to the next step. What kind of food are you interested in? For example, pizza, Chinese, American, etc.
Burgers.
I found some burger options for you. Here are the top 3 matches. 1. Burger King, located 1.7 miles away. 2. Jumbo's Frozen Custard, located 0.06 miles away. 3. Brazen Head Pub, located 1.2 miles away. If you would like more information about any of these options, please let me know.
No, that's all. Thank you. Goodbye.
You're welcome. If you have any more questions in the future, feel free to ask. Goodbye and have a great day.
All right, so that's just like this much text. Just write down like, and a couple of functions integrated to tell it to gateway to some rapid API. One to look up an address, one to feed the location ID from the address back to a search, and like so those are all kinds of things like. That's the fun part, so you don't have to do all the boring part of making the infrastructure or the bot itself. Like you're just wiring it in to look up functions and stuff like that. So that's really kind of the main goal for the whole thing, right? So we are inspired to do this, and what's important is that if we wanted to do this and we didn't already make SignalWire, it would have taken us forever because all we had to do is extend SWML, add another verb, and call it AI, and then we did more JSON, a couple more parameters, and then we have like an instant scalable deployable point of entry to the network. So you can essentially create even like a static program like that. Like that example I just did is one static file. Even the part that uses the APIs, because we have like a templating engine. So all you have to do is like put your keys in there into environment variable and tell it where the APIs are and which information to extract out of it, and it will just go through the whole thing. So it really changes your focus to what's important, and that's kind of what we're after. So we're doing the same thing with the next phase of stuff that we're doing. So we're trying to just take some of this like really hard to get out there, things that are sort of paywalled to really large organizations that want some like $50 a month just to have like one user and be able to make that as a wholesale tool, and you can wrap what other cool stuff you want around it. So you can have authenticated users that have like their own area, and then they have a public area. So one of the things that's interesting is like what we noticed watching the evolution of call center from back to when it was all physical stations up to where it's becoming more and more virtual, is that you would run into this issue where you have these different systems and you can't integrate them with each other. So you have like this physical phone network and all the calls are coming in there, but then you want to do stuff on your website too, but then you have to do it completely differently. And then half the time you're just paying someone to answer the phone and look stuff up on the website rather than kind of integrating everything. So with the advent of all the kind of, WebRTC is mature now. We have SIP is going to not go away, even though we're not big fans of it, but we spent 20 years making it easier, so we have it and it's there. And we have, classic phone network. And we have this whole idea that we are going to make it less about phone numbers and more just about your identity on the internet. And then putting behind that accessibility to all the ways that you want to be communicated with. So whether it's like, you could have 3 mobile phones, a UCAS app on one of those mobile phones, a physical line somewhere in a cabin, and some kind of Polycom from 10 years ago that you still have hooked up and registered. And you can use all those at the same time. Someone just tries to call you by your name, your choice. You can make all those things ring simultaneously, or you can just have one of them. And by doing that, that allows that paradigm to just exist instantly. So it's not something you have to build, like that's not the product. You're trying to leverage that inside of you're making a product that requires a bunch of users to be able to be accessed from anywhere. So it gives you kind of a DNA for creating any kind of thing that is an evolution of UCAS rather than just like repeating the exact same product over and over again. And one of the things that's really good about this is you can automatically integrate some of these features. So like you're on your website and somebody wants help, you, instead of the annoying fake let me chat with you thing that pops up, you can actually like press a button and call. And you're not just making a one-off application to call, like your actual telephone network that you've built with us is where that call will go. So if someone dials your 1-800 number, they dial one of the phone numbers of your employees, or they go to their website and press I want to talk to somebody, it all hits the same logic and it gets distributed to everyone. So that's really what we're after, because we know that that's the thing that everyone keeps building and they only kind of build it. And it's great, as in the old days we were consultants when there's like 2 of us in the company and 3 and 4. We never got really bigger than like 5 or 6 people before we kind of got to the next stage. Before we built SignalWire, we were a little tiny team and we helped everyone make some really cool stuff. And it was always the same problem. It would be scalability, what do I do once I hit so many servers? And it would be like, how do I like connect all these different paradigms into one? So that's what drove us to have this focus, is because we think that we can solve it in a way that allows developers to just pick and choose which interfaces they want to connect to, what protocols, and everything they're working on is what makes their company and not being forced to build their own stuff. And I had this back in the, being old as I am, lived through kind of the dot-com bust in the 90s. And back then it was like such a wild west that if you wanted to be an internet company, you needed to have the internet come to your building. If you had an office, you had to get one that could have the internet circuit to it and put your own servers in and install your own email, you know, and manage it, and then someone would hack it and start dictionary attacking you, and you're like, what is this? And you're like dealing with all this kind of stuff that is like all before you even started doing what your actual business was for. You just wanted to have a website and some email, and you had to host it all yourself. So it's really kind of repeating itself over and over again. That's what you could fill in that story to almost any cloud journey, right? Any kind of cloud hosted stuff started that way. Computers are the same way. They started making VMware and the AWS and everything. It's all hosted, and like you don't have that problem anymore. So we're kind of just trying to do the same thing because we can't. We're too old for this shit, basically. Like, we don't want to keep helping everyone re-implement the wheel over and over again, so we're just trying to make a really cool wheel that you can build stuff on top of. And I think that give us another couple months and we'll continue to have cool stuff. I'm hoping that by the time I'm here next year, it'll be a really great update. These ideas aren't new. Like, it's the only reason that we're even here. It's great that we finally have found a way to kind of distribute and make FreeSwitch accessible to everyone. And everyone that likes using it from the open source, there's a talk tomorrow. They're going to go over the engineering of it, to talk about the new release that came out and everything. And basically, if anyone has any questions, this is a good time. I still have like 9 minutes left. So.
This is a great time for questions. You're quite right, Tony. Thank you. So, who's got a question for Tony that they'd like to ask? A very rare opportunity to jump in front. I think we've probably got mics running around the room if we need them for that very purpose.
No one ever asks questions in my keynotes. It's 19 years.
Do you think it's because you're a bit intimidating, Tony?
Maybe you could ask me one.
Well,
you're good at coming up with questions.
Yeah. Well, here's what strikes me is I know that some of the things that have come to fruition just in the very recent past, you've had in mind for many years.
Yep.
I know that from when I was working with you guys in SignalWire. I don't know really how to frame the question, but how can you do it? How can you have that vision for stuff that hadn't occurred yet and kind of keep it in the back of your mind to bring it out when it's the right time?
I think it's partially because it just took that long to do it. Maybe we didn't know better that it was hard and we're dumb and we just started doing it. You know, we didn't know that what having a conference was either, and we just did it anyway. The first ClueCon was just random. Let's just like have a conference, you know. So I think we're like, how hard can it be? Let's just start some software project. And then we were able to, I mean, for me, I'm a child of Unix. Unix was my first computer, not any other operating system. I was just lucky that way. I didn't have a computer. I had to go to university, and so my first experience with the computer was like a VT100 terminal. So I've always been obsessed with it. And when I made FreeSwitch, I wanted to make it in C because that was my favorite language, because it's what Unix is made in, and it's just an extension of it. And like, I think maybe you could give a lot of credit to that, the foresight of who made you know, the first Unix prototypes back in whatever, I think it was like 70s or something, right? So like, that same philosophy and culture has influenced me to the point that I designed a lot of the software in FreeSwitch to be from that same Unix. Everything fits inside each other. You can extend things and daisy chain things together, concepts, and then took it even forward now. And then into SignalWire, it's just kind of spreading into even bigger things. So I think that was one of the, maybe the lucky things that happened, was that maybe if I would have gotten like a Windows PC first, it would be a whole different story.
Yeah, there's actually a name for the process you're describing that I've heard in England called BAYF, B-A-Y-F, build as you fly. So you don't know really what it is, but you start doing it anyway and kind of build it as you go along. Thank you for that. Any questions from the floor here for Tony? Okay, well, if that is the case, Tony's going to be around, because he would be around for ClueCon for the whole time. So if you want to speak to him privately, you can do that. We're just going to have then a little 8-minute break for you to stretch your legs very quickly, and then we'll be back with Fred here at 10:45. But in the meantime, let's give Tony and the whole ClueCon team a massive thank you.